Good afternoon. In today's session, we have to study about our fourth unit, that is nothing but DC machines. We will wait for other students for 1 minute. Then we will start our today's session. Just wait for a minute. So our fourth unit is DC machine. DC machines are electromechanical energy converter because these can convert electrical energy into a mechanical or vice versa. It means what? We can say DC machine as a electromechanical energy converter which work from DC source and which will generate the mechanical power or which will convert mechanical power into a DC power. So we can say the DC machine is said to be as a DC generator if it is converting mechanical energy into a electrical energy. And if it is doing exactly vice versa to the DC generator, at that time we can say the DC machine as a DC motor because it will do vice versa of a DC generator. It will use the electrical energy and it will give us mechanical energy. So these are the two types for the DC machines which we have to study in this our unit. This is the theoretical unit. We have finished the numericals unit. Our first unit, all the theorems, Kirchhoff's, then superposition, Thevenin, Norton's, power, maximum power transfer theorem, source transform. Then our second unit, two-port network, in which we have studied about RL, RC, RLC network. Then we have studied about the two-port network parameters and the functions, in which we have seen the different parameters like hybrid, admittance, ABCD, transmission parameter, Laplace transform, how to solve the differential equations easily. Now we are moving to the theoretical part. So in our syllabus, now we are supposed to study about the DC machines. This is our fourth unit. After that, we have to study about the AC machines. This is nothing but the induction machine. Then we have to study about the electrical vehicle. So now onwards, there will be only theory part. There will be some numericals. Only in this unit, some numericals. These things will be on the EMF and the torque equation. So firstly, we will see how we are supposed to use DC machine as a DC generator and how we are supposed to use DC machine as a DC motor. So here, what we are saying, if we are using the motor, at that time we can use electrical energy and we will get the output that will be in the form of mechanical energy. So we can say this device as a DC motor because if you see, it will use the electrical energy and it will give us mechanical energy. If you see the construction for the DC motor and the DC generator, construction are exactly similar. Only what is the difference? Here, if you see, here we are using the electrical energy. But when we are supposed to use the DC generator, at that time, it will use the mechanical energy and it will provide us output that will be in the form of electrical energy. So we can say for a generator, input energy will be a mechanical energy and we will get the output that will be in the form of electrical energy. So we can see here N and S, these are nothing but the poles. These are the poles. We will see one by one. After that, you will get the things. So what we are saying, we are supposed to use the DC machine. That will be in the form of DC motor or that will be in the form of DC generator. It means what? In our syllabus, we are supposed to study about DC generator and the DC motor. So if we are saying, if we are using the electrical energy and we are giving the output that will be in the form of mechanical, at that time we can say that type of a motor as machine as a DC motor. And if DC machine is doing exactly vice versa to the DC motor, it means what? It will use the mechanical energy and it will give us energy that will be in the form of electrical energy. At that time, we can say that type of machine as a generator. So here, if you see what we are saying about the motor and generator, motor is using the electricity because it is using the electrical energy. And what about generator? It will generate the electrical energy. It will generate the electricity because it is using the mechanical and it is giving us electrical energy. Then what we are saying, we are supposed to study about the construction of DC motor, DC generator. At that time, you will get this point. What we are saying, driven element. It means what? Where we will get the output. The shaft of motor is driven by the magnetic force developed between armature and the field winding. And here the shaft is attached to the rotor. It means what? When we will give the electricity, when we will give the power supply, at that time, the shaft will rotate here. But if what we are saying about the motor, the shaft is driven by the magnetic force. But in generator, the shaft is attached to the rotor, so it is driven by the mechanical force. if you see if you see about current at that time, you can say in a motor the current is to be supplied to the armature winding. It means what? We can give power supply to the armature winding, and armature winding is nothing but it is the rotor of the motor. Rotor means what? It means it is the rotationary part of the DC motor. In the generator, current is produced in the armature winding. It means what? In generator, we are producing the EMF, so we can say current is also produced. But here we are giving the electrical energy, so we can say about the DC motor, current is supplied to the armature winding. About what we are saying, if you see about the DC motor and DC generator, at that time, motor will follow flaming left hand and DC generator will follow the flaming right hand. We will see these rules when we are supposed to study about the working of DC motor and DC generator. At that time, I will explain these things. What we are saying, if you see for some examples for the DC motor and the DC generator, electrical car or a bike which is using the electrical energy and which will give us the energy that will be in the form of mechanical energy, that will be in the form of light, that will be in the form of heat, that will be in the form of anything that will be in the mechanical. So we can take example for the DC motor as a electrical car. If we see about the DC generator, we can say example as a DC generator, or we can say energy which is produced in the power station. That is also the form, also the example for the DC generator. Now we see about the construction. What we are saying about the DC generator? We are saying we are supposed to use the electrical energy. We are supposed to use the power, but when we will give the power, at that time mechanical energy will be used, and that device which will generate the energy, that will be in the form of electrical. So we can say about the DC generator like it is an electromechanical converter which will uses the mechanical energy and which will give us electrical energy. So we can say this device as a DC generator, or we can say as a electrical generator. If you see for the constructions of these machines, we can say it mainly consists of the main three parts. These are nothing but magnetic field system. We are saying here magnetic field concept. It means what? There is a concept of induction, because we are aware about the inductor. Inductor will store the energy that will be in the form of magnetic field. Just wait for a minute. Someone is facing issue. Nishiganda, is there any issue? Why you have raised your hand? Okay. So what we are saying about the construction, it is consists of the main three parts. These are nothing but magnetic field system, armature winding, and commutator with brushes. So if you see the other parts for the DC generator, there are lots of parts like magnetic frame, the outer covering of this. We are saying as a magnetic frame, and it is called as a yoke. After that, there are number of poles, And these poles are working as a conductor because on that we are putting the field winding. After that, it will consist of pull shoes, field winding, or we can say field coil, armature winding, or we can say armature core, brushes which we are put on the commutator, bearing and the shafts. We will see one by one. What we are saying about the DC machine, if you see the DC generator construction will look like this. The outer covering, this is the outer covering. We are saying the outer covering as a yoke. So if you see for the DC generator or the DC motor, theoretically DC generator and the DC motor both are having the same general construction. Only what is the difference? We are saying here the shaft is attached to the rotor, and here the shaft is driven by the magnetic force. Only there is a difference in the construction of armature. There is little bit difference. But if you see theoretically, both are having the same constructions. So we will see all these parts which we are using in the DC generator and the DC machine. So we are saying frame is the outer, the black. This is the black circle, outer covering. So we can say about this line, the outer covering, as it is the stationary part of a DC machine. It means what? DC generator or the DC motor, on which we can put the main poles and the commutator. Poles are nothing but these are the poles. ये जो है, the four poles. If you see for this DC generator, it is having the four poles. So we can say about the frame, it is the outer covering for the DC motor or a DC generator. It is the stationary part of the DC machine on which the main poles and the commutator poles are bolted, which will form support by connecting the frame to the bed plate. And if you see inside the outer covering, the frame, we are putting the yoke, and yoke we can make yoke by using the cast iron, or we can use cast steel, and it will give support, protection to the assembly of the DC machine. It means what? ये जो yoke है वो क्या कर रहा है? वो DC machine को support दे रहा है. If we use the cast iron to make these poles, ये जो four pole है, if you see, we are saying these as a poles, so we can make the poles by using the cast steel or the cast iron. If we use the cast iron, there may be chances of blowholes in it while casting. So here we can use cast steel, it's used instead of the cast iron. There will be questions sometime on the numericals. Why we are using the cast steel instead of the cast iron? So what is the reason? It will produces the holes in the casting. After that, what we are using here? We are using the poles. So this we are using the poles. These are the solid poles, and we can make these poles by using the steel. After that, what we are saying, when we are using the poles, at that time, we will require the pole shoes. We will require the pole shoes. The same diagram I am writing again. Same diagram again I have drawn. What we are saying here, outer covering we are calling as a frame. After that, there is a yoke which is give the protection to the assembly of the DC generator. After that, we are using the poles, and these poles are generally laminated, and sometimes these poles are made up of the pole body as well as it is having the pole shoots, and we can use the same lamination which we are using for the pole to make the pole shoots. They are usually made up of copper. So these can be used as a conductor because we are aware about the copper property. It is a good conductor. So we can say they are usually made of the copper. They are wound in a such a way that when they are energized, they form alternate two poles. These poles are nothing but north and south. If you see, I have shown you how we are using this pole coil. So we are saying, we can see here on the format means on the side we are using their copper. This is nothing but the copper wire because it is a good conductor, and we are putting the filled coil which are former, and these are wound on each pole, and these are connected in series. If you see, these are connected one by one after 1 2 seconds. So we can say these are connected in series, and when they are energized, they will form two poles. These are nothing but north and south. After that, what we are saying, we are using the pole. Sometimes pole are usually with the pole shoots. We are calling this as the pole shoots. So we can say the poles are joined to the yoke with the help of welding, or we can say it can be joined with the yoke. Yoke is nothing but the outer covering. ये जो blue वाला है, the blue circle, the outer covering. So we can say about this as a pole shoes are joined to the yoke with the help of welding. It carries and support the field welding. To support the field winding, pole core provides this area to wound the field winding and to spread out the flux. Because here we are using the field winding. Field means what? Here we are using the coil. And we are aware about the Faraday's law. What Faraday's law states that when there is a conductor which will cut by magnetic field, at that time it will produces the magnetic flux. So we can say here the pole shoots are carries the field winding. So to support the field winding, the pole core area will provide to the field winding and to spread out the flux in the air gap, because when we are putting the cut, putting the conductor in the magnetic field, at that time according to the Faraday's law, flux will produce and to spread out this flux in the air gap. Because if you see the construction for the DC generator, at that time you will see there is a air gap in the commutator to get the air. So we can say to spread out the flux in the air gap, there are pole shoots available. And the pole core direct the magnetic flux through the air gap, armature, and to the next pole. So according to the direction of yoke, we can derive how the direction of flux. So here, if the direction of flux is yoke is decided, after that, according to which pole direction will decide it. And if you will give the power supply at that time, as the magnetic flux will get introduced, that time pole will start to rotate, and armature will also rotate, because armature winding is the rotor of the DC machine. So it will decide how the next pole which is connected in the series with this pole, because if you see construction, we are connecting in series one by one. So now we are saying the fourth part. This is nothing but the armature. We can say armature core, it is the rotor of DC machine, and it is constructed by laminated sheet of the silicons. It is a cylindrical in shape with the slots to carry the armature winding. If you see, armature core will look like this. And we are putting here the gaps. We can say this as a slots. ये जो gaps है उसको हम slots बोल सकते हैं. और जैसे तुम्हारा सीढ़ी होता है, like this, it is in a circular. And there are the small holes. We can say these as air holes, and these are available to get air for the cooling purpose. Because when we will give the power supply, क्या होगा? We are saying armature is a rotor. Rotor continuously rotate होगा. And continuously rotate होगा. उसका meaning क्या हो रहा है? It will require large amount of power, and it will produced in the form of heat. मतलब heat generate होगा. Power dissipation जो होगा, it will be in the form of heat. So for the cooling purpose, We will require the air. That's why we are putting there these holes, air holes. So we can say the armature is made up of the thin laminated circular steel disc to reduces the eddy current losses. Eddy current losses means what? If there is not good earthing, if there is any wrong connection in the power supply, at that time, if there is current will flow. That current we are calling as the eddy current. So we can use here still this to make the armature winding, so it will reduces that eddy current losses, and it may be provided with the air duct for the axial air flow for the cooling purpose, and armature is key to the shaft. Again, we are saying there is armature winding. On the armature, if you see here, this is the armature core. And we are saying here we are using on the armature core, armature winding. So the armature core slots are mainly used for holding the armature winding, because on that core we are making the winding. So we can say about the armature core as these slots are used for holding the armature winding, and these are used in the closed circuit, and it is connected in series to parallel